final one we're going to go over together with everything. If you are a color person, you might want to color code things as you go along. So that part is up to you. But I want to talk about filling this out. So the first thing, I want to put our degrees on here. So we have done this before. We know this is like 0 degrees, or if you prefer, you can call it 360 degrees. You don't have to do both. And then we did our common angles, so this would be 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, then what should we do? Right. We jumped down here and said that's 180 degrees. So then we have to subtract our reference angle. So 180 minus the 30 is 150. 180 minus the 45 is 135. 180 minus 60 is 120. What do we do for the third quadrant? Add 180 plus 30, 210. 180 plus 45, 225. 180 plus 60 is 240. And right here, this would be 270. And then how do we get the points in the fourth quadrant? So 360 minus 30, 330. 360 minus 45, 315. And 360 minus 60 is 300. So I know we did that quiz last week and you guys did pretty well with that, so I know you can do this part. Next thing I want to add in is the radians. So my radian measures. 0, you could call that 0 radians, or what's the other one you could call it? 2 pi. Okay, 30 degrees is pi over 6. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. If we jump down here, 180 is pi. And then we talked a little bit about the reference angles. All of these will have a reference angle of 30, which is pi over 6. So all these will be something pi over 6. All of these are 45. So all of those will be a something pi over 4. All of these are the 60s, so that would be pi over 3. And then we talked about patterns for the numerator. In the first quadrant, it's always just pi over. What's the pattern in the second quadrant? One less, because it's smaller than 180. So it'll be 5 over 6, 3 over 4, 2 over 3. And then the third quadrant is one more. So 7 over 6, 5 over 4, 4 over 3. What would this one be? Mm-hmm. And what's the pattern in the fourth quadrant?
Times 2 minus 1.
Mm-hmm. Times 2 minus 1. So 6 times 2 is 12, minus 1 is 7. 4 times 2 is 8, minus 1 is 7, 3 times 2 is 6, minus 1 is 5. Okay, so that's the part that we have done before. Are there any questions there? Okay. Then, the next thing we are going to add on here is ordered pairs. This is a unit circle. That is a circle with a radius of 1. Okay, if you have a circle with a radius of 1, thinking back to the first chapter, what was the definition of sine in terms of x, y, and r? Y over r. And on this circle, since the radius is 1, that means sine is just going to be the y value. Definition of cosine is x over r, but if it's a unit circle, that's a circle with a radius of 1, that is x. So we are going to add ordered pairs to this. The x is your cosine, the y is your sine. Okay, we have done some of these points already. You know, right here, I don't even need to think about cosine and sine. I know that would be the point 1, comma, what's your y value there? 0. What's this point?
0, comma 1.
This is the point
Negative 1, comma 0.
And this one down here would be
0, comma negative 1.
those were the 4 that we've already used. Alright, so let's go through the first quadrant and work on our order pairs. The x value is the cosine. So think about your hand trick. You know, cosine of 0 is 1, which we have. Cosine of 30 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Cosine of 60 is radical 1 over 2, which is 1/2. Cosine of 90 is radical 0 over 2, which is 0. If we did our sines, sine of 0 is 0. Sine of 30 is 1/2. Sine of 45 is radical 2 over 2. Sine of 60 is radical 3 over 2. Sine of 90 is radical 4 over 2, which is 1. Does everybody see how I got those ordered pairs? It's just like the hand trick. The x is your cosine, the y is your sine. Alright, when I go to the second quadrant, just think about if you're going to plot a point in the second quadrant, you went backwards. The x value is negative. Y is positive. So it will be the exact same points as over here, except the x is negative. So everything with a reference angle of 30 is still using that order pair, but my x is negative. So it's negative radical 3 over 2, 1/2. Okay, this one was a 45, so I'm using my 45 ordered pair, but the x is negative. So negative radical 2 over 2, positive radical 2 over 2. Okay, for my 60, it would be a negative 1/2. And a positive radical 3 over 2. Okay, in the third quadrant, what do you know about your points?
Exact same way, right?
Yeah. So the 30 is the same as my ordered pair for 30, but in the third quadrant, when you plot a point, x and y are negative. So at 5 pi over 4, we're using negative radical 2 over 2, negative 1/2. Sorry, negative radical 2 over 2. 4 pi over 3, we're using the pi over 3 point, negative 1/2, negative radical 3 over 2. Okay, what about if you have a point in the fourth quadrant? What's true?
Well, y is negative.
Yeah, x is positive and y is negative. So my 11 pi over 6 would look like the pi over 6 point, except the y is a negative 1/2. 7 pi over 4 would look like my pi over 4 point, except the y is a negative radical 2 over 2. 5 pi over 3 looks like pi over 3, except the x is a negative radical 3 over 2. So this is the complete unit circle with everything we will put on here. Some people don't really use this a whole lot. This is nothing we haven't already done. You know, on your quiz, I gave you questions like cosine of 5 pi over 4, and you wrote down quadrant and reference angle and evaluated it. But if you know your circle, you could look cosine of 5 pi over 4, that's just the x, and so it should be negative radical 2 over 2. So it's just like another layer to help check yourself. I'm just throwing a lot of tricks at you. We're doing a little bit at a time, and so that hopefully something makes sense to you. As far as tests or quizzes, I won't, like on the test, I'm not going to make you fill out one of these complete circles, but I have some people that really like it and ask for a blank circle to fill out, and that is certainly okay. So from here on out, if you really like this and you can fill it out, you can have a blank one anytime you think it would help you. Okay? So today, we're really not learning anything new. We are just doing some practice with this stuff. One thing I want to mention, we have seen this formula before, but remember, if we were talking about a triangle, x squared plus y squared equals r squared. In the unit circle, your radius is 1. We know the x is cosine, y is sine, equals 1. This is that one Pythagorean identity that we used in chapter 1. I gave you 3 of them. I said this is the only one that we really use a whole lot. Just showing you it comes up again. Sine squared theta plus cosine squared theta equals 1. And we will use that more in chapter 5. We'll look at it again. So just circling back around there. So let's say I wanted to find the exact values of all of these things. Let's talk about how we could do it. If you were thinking about your circle, 3 pi over 2 is right here. What is that point on your circle?
0
So
there, 1.
sine, is that x or y?
1.
So sine 3 pi over 2 is negative 1. Cosine is the x, so cosine 3 pi over 2 would be 0. Tangent Tangent is y over x, or you could think of it as sine divided by cosine. So -1 divided by 0, which is undefined. I guess I usually write undefined, but you can put the symbol too. And then obviously if you wanted secant, you would just do the reciprocal of cosine. If you want cosecant, you do your reciprocal of sine, and so forth. Okay, here's your problem. I want cosine and sine of 7 pi over 4. Okay, so we've done these before. What quadrant is 7 pi over 4 in?
4.
Reference angle, you just ignore the 7, is pi over 4, which is like 45 degrees. In quadrant 4, is cosine positive or negative? Positive. Cosine of 45? If you're using your circle, look at 7 pi over 4, my x was a positive radical 2 over 2. So we can check that way. Sine, in the 4th quadrant, is sine positive or negative?
Negative.
And sine of 45? And that's the same as the y value of that point on the circle. Okay, what if I gave you a negative value? What do we do if we have a negative there? Add 2 pi. Okay, that's like 6 pi over 3. So -5 pi over 3 plus 6 pi over 3 is just pi over 3. So that's quadrant 1. We know that's positive. Couple ways to get it. If you're using your circle, you can go to pi over 3, and tangent is y over x, and divide those things. I prefer to use like my hand trick and just a circle to double check myself, but it's kind of up to you. So tangent of 60, if I fold in pi over 3 is like 60. Tangent square root of the top over square root of the bottom, so radical 3 over radical 1 is just radical 3. Okay, you guys, last one like this, do cosine of 2 pi over 3 for me. What quadrant is that?
2.
Reference angle,
60 degrees.
like 60, so that's pi over 3. Okay, so in quadrant 2, sine is positive, that means cosine is a negative. Cosine of 60 is radical 3 over 2. So far, so good?
Wait, so cosine's x, right?
Mm-hmm.
What-
I
what did we
did
get?
sine, didn't I? I just did sine of 60 instead of
Yeah.
cosine of 60. Sorry, cosine of 60 is 1/2. Thank you. If you look at your circle, see, I did that on purpose so you would realize you used the circle, double check yourself. Alright. I want to talk about a few problems on our calculator. So let's say I give you cosine of 1.85. Okay, if I am looking at this one. First of all, does that have a degree symbol on it? No. And if I don't have a degree symbol, then we assume it is radians. So, You're going to go to your calculator, make sure you are in radian mode this time. And then we just type in cosine 1.85. I get a negative 0.2756. So now we have both options. We are going to go back and forth between the different modes. Second one, cosine of 0.5149. And we get 0.8703. So double check, try those on your calculator, make sure you are getting the same answer. So just as a refresher, so I know we've evaluated these things in degree mode before. If I wanted cotangent, how do we type in cotangent? Yes. We don't have a cotangent button, but we just do 1 divided by tangent. And we get 0.2552. D, how do you type in secant? 1 divided by cosine. You guys getting all those? Last ones that I want to look at. I want to find an angle between 0 and pi over 2. If you're between 0 and pi over 2, what quadrant is that?
4.
Okay. If cosine of s is equal to this. When you want the angle, we have to move this cosine to the other side. How do we rewrite that?
0.9685
Not divided by cosine. What do we change the cosine to when we move it? We've done it before. Yeah, cosine inverse. So that's when you do that cosine -1. Thank you. So if I type that in, second cosine, I get 0.2517. That is between 0 and pi over 2. Pi over 2 is like 1.57, so it's between those. So that's our final answer. One more. This one is slightly different because the last one I said approximate. It wasn't something we knew. But now I'm saying find the exact value. Anytime I ask for exact values, that means don't put it in a calculator and give me that decimal. I want the true value. If you are between pi and 3 pi over 2, what quadrant is that?
2.
Okay, I want to know when tangent is equal to 1. Is that quadrant 2? If you're between pi and 3 pi over 2? Which quadrant?
Oh, no, that'd be 3.
Yeah, quadrant 3. Okay. Let's start with the reference angle. Think about your hand trick. When is tangent 1? Tangent of 0 is 0. Tangent of 30 is 4. Yeah, 45 degrees. We are in radians, so 45 degrees is the same as pi over 4. Okay, in quadrant 3, we know the numerator is 1 more than the denominator, so that would be 5 pi over 4 is our final answer. Now, if you think about the circle, I'm asking between pi and 3 pi over 2. So here, when is your tangent going to equal 1? When is y over x going to equal 1? And we can see it's right here, because you divide those and you get this. That angle was 5 pi over 4. Any questions for me? I want to give you guys time to work. So here is the assignment. Although, I think I actually just want to go, I don't want to go to 72. Let's stop at 68. So 2 through 34 even, 52 through 68 every other